going to start now. All right. So it's time, everyone. It's time. It's already 6:30, and we're going to get started with today's lesson, which is like lesson 1 of a series of 3 revision lessons before the fast calculation competition. And this is going to be pretty much an easy lesson on the powers of rational numbers. Okay, so do you all know what are rational numbers? Have you all heard of rational numbers before? So like probably you can give me some examples of rational numbers in the chat if you know what rational numbers are. Ah, Anthony, so you know that it's not I. All right, those are real numbers if you're saying. Yes, not pi, something like that. So basically any numbers that can be expressed as a fraction with integers as numerators and denominators. So a rational number can be a decimal, it can be a fraction, it can be an integer, but then in the end, we can convert it into a fraction with integral numerators and denominators. Yes, yes. And of course, it includes all the integers. Yeah, very good, very good. And today we're going to be talking about the powers of these rational numbers. All right, so we are not going to learn about how to calculate the powers today, but it's more on the definition side of things. So first of all, we need to know that a positive power of a number describes the number of times that we are using that number in multiplication. Or in other words, we can say that it's the number of times that I am multiplying the base number by itself. So for example, if I have the base number 2 and the power number 3, I would be multiplying 2, the base number, by 3 times, which is the number that we have in the power or in the index or in the exponent, whatever name you're calling it. All right. And also do be very careful that when you're trying to write down a power, you need to write it as a small number on the top right corner of the base number. Yeah, so just be careful that you can distinguish the base number and the power number. So you can't write it like, for example, like this. Otherwise, you won't know if it is 23 or if it is 2 to the power 3. Yeah. So that's quite important, which is something that many of you might just make a mistake in. Yeah. So there's something that you need to remember. So here we have an example with A, the large number, as the base, or the base, and N is the power. All right. So another simple example, if I have 2 to the power 4, it means that 2 is multiplying itself for 4 times. So far, are you all understanding it? Yeah, you can just type a 1 in the chat box if you understand it, or type a 0 if you don't. Yeah, sure. All right, so I believe this is pretty simple. Yeah, thank you. So now, let's have a look at these questions. I think this will be pretty easy for you, right? First of all, we have 2 to the power 1. What is 2 to the power 1? It is 2 multiplying itself for 1 time, which is just 2 itself. Yeah? Yes, definitely. And what is 2 to the power 2? It means 2 times 2, right? Yeah, so I believe you do know the powers of 2. And then when I have 2 times 2 to the power of 3, it is 2 times 2 times 2. Or we can also say that it is 2 to the power 2 times 2. That's 8. And then so on. So we're going to have, well, I'm just not going to write each one of them, but essentially, you know that there's going to be 4 times. That's going to be like 5 times of 2. And 6 times of 2, right? And the answers are going to be 16, 32, and 64 respectively. Your notifications are pinging. Well, probably you can turn your notifications on mute, I think. Yeah, but yes, you're getting the correct answers. Very good, very good. And well, of course, I don't expect you to calculate these simply. What I was trying to say is on the next page, actually. So if we have -2 to power 1, what is the value of it? It is just -2 multiplying itself, right? So that's going to be, yes, -2. That's right. And if I have -2 squared, what's going to be the value of it? Yep, it's going to be -2 times -2, which is 4. And if I have -2 cubed, it's going to be equal to -2 squared times -2, which is 4 times -2, and that's -8. And well, do you spot a pattern right there? Sort of like a pattern right there. So you can see that if you're comparing the values or the numerical values of the numbers on this page, that's going to be the same as the numerical values of the numbers on the previous page, right? But then, since this time we are taking the powers of a negative number, we need to notice whether the outcome is going to be positive or negative. And basically, we know that 2 negatives is going to make a positive. So if I have 2 negatives, that's going to be a positive, right? Which means that if I have some powers, I can group every 2 negative numbers and make it a positive product, right? So that's the reason why when I have odd even powers, it can't be made into complete groups of 2, which means that a negative number or a negative base number is going to be singled out. Yeah, that's right. If the power is odd, then the answer is negative if I have a negative base. So you can imagine that it's going to go by negative, positive, negative, positive, negative, positive. Yeah, so I'm just going to omit these. I'm pretty sure you know how to expand it. So as a conclusion, whenever we have even powers, no matter the base number is positive or negative, we end up with positive answers. All right. And whenever we have positive bases, no matter the power is even or odd, we always end up with positive answers. But then, if we have negative bases, and at the same time, we have odd powers, we are going to end up with negative answers, all right? So it means that we need 2 prerequisites for a negative answer in a power, which is, firstly, a negative base. Secondly, an odd power. All right, satisfying both conditions at the same time, and we're going to get a negative outcome or a negative answer there. Does it make sense to everyone? All right, so if any of the 2 is not satisfied, we will have a positive answer. That's right here. Okay. So at last, sometimes we are going to have some parentheses when we are calculating the powers. And if I am including the sign inside the parenthesis, it means that the whole thing is considered as the base. All right, so the whole thing is considered as the base, which means that if I have -2 in brackets squared, it would be equal to -2 times -2, which is 4. All right, so that's going to be the case with parentheses. If I don't have the parentheses, it means that the square or the power is only associated to the 2 as the base, where the sign is put in front of any calculations we have after that. So we have -2 squared, which is 4, and with a minus in front of it, because the minus is disregarded from the base without the parentheses. Okay, so this is something that you need to pay 200% attention, because it's super easy to make a mistake when we have some parentheses involved in the negative numbers and powers. All right, so this is what I hope you can all learn from this lesson today. All right, I think I have done enough of the talking, so we'll be moving on to some questions which we can do together. So for this question, we are not required to calculate the values of these powers. We just need to know whether they are positive or negative. So for the first one, if I have 3 to the power 4, is it positive or is it negative? So you can just type a plus or a minus in the chat box. Yes. Yes, very good. It is going to be positive, right? It is going to be positive because it is a positive base. So it doesn't really matter what is the power. And what about the second one, 3 to the power of 5? Is it positive again or is it negative this time? Yes, very good. It's going to be positive again. Brilliant. Now moving on to the second one. If I have -3 to the power 4, is it going to be positive or is it going to be negative? Yep. It's going to be negative because it doesn't have parentheses around it, right? Which means that I'm calculating 3 to the power 4 first and then putting a negative sign in front of it. So it's going to be negative. What about -3 to the power 5? Is it positive or negative? Yeah, that's right. I can see that you are getting the correct answer. The most of you are. Well, so far I didn't see anyone saying positive here, which is definitely right. Because again, it doesn't have any parentheses, which means that it's going to be negative. Good. What about -3 in brackets to the power 4? Is it positive or is it negative? Yes. This is positive design because we have a negative base and an even number power. So whenever we have an even number power, it's going to make it positive. What about the last one? That's right. The last one is negative because it satisfies both conditions at the same time. Negative base and odd power. So once it satisfies both conditions, it's going to be a negative power. It's going to be a negative power. All right. So that's it for exploration 1. I can see that you're all doing really well in it. Which means that for the next one, we're just going to move on to some numerical calculations. All right, for the first one, what is 2/3 to the power of 3? Basically, we just need to write it out as a multiplication expression first. if you don't know how to split it up, all we need to do is that I know 2/3 to the power of 3 is 2/3 times 2/3 times 2/3, right? Yeah, which means that I have 2 times 2 times 2 over 3 times 3 times 3. Because for multiplication of fractions, I know I can multiply all the numerators together and all the denominators together, right? And yes, 3 of the 2's multiplying together is going to give us an 8. 3 of the 3's is going to give us 27. Well done. So what about the second one? Now that I have removed the parentheses, is the answer going to be the same? No. No, because the power of 3 is only exclusive to the 2 now. So 2 is the base number here instead of the whole 2/3, which means that I have 2 times 2 times 2 over 3. That is 8 over 3. Good. And what about the third one? If I have minus 2/3 over 3, what's that we're going to have? Right. So for these kinds of questions, we can just take it as 3 steps. The first step is we can determine the sign of the product. So we have a negative base and an odd power. So it satisfies both requirements, which means that it's going to be negative. And then for the numerical value, that's going to be the second step we're looking for. So the numerical value is going to be 2/3 to the power of 3, which we have from section 1. That's going to be 8 over 27. And the third step is to put them together, and we get the answer. Right. So that's going to be the third one. And then the last one. What about the last one? Some say positive 8/3, some say minus 8/3. So we have a minus sign there. And then we have this thing, right? Which means that we can just first try to copy the minus sign down. And then for this section, we have -2 in brackets to the power 3, which is going to be minus, because I have a negative base and an odd power. And then 2 to the power 3 is going to be 8. So we have -8 over 3. And then we have another 2 minus signs right there, a minus and a minus, which is going to make a plus. So of course, we're not writing out the plus since it's positive. And the answer is just going to be positive 8/3. All right. Yes, that's right. So hopefully we're all good so far. Then let's move on to exploration 3. So you can see that in exploration 3, we have a lot of inequations right here, or some comparing powers question. So we're just trying to compare all these powers. So do I need to say, for example, calculate each one of them one by one? Like there's quite a lot of numbers altogether, right? So do I need to determine these solutions or these choices one by one? No. Yeah, no. And I'm pretty sure that you have realized for these 4 options, the numbers that appeared in all of them is mutual, right? So it's the same 3 numbers, or it's the same 3 powers that we're comparing, which means that in the end, I just need to calculate each of these 3 powers, and I will be able to compare the values of these 3 powers, right? So the first one we have is -2 squared. What is the value of this expression? Yeah, that's right. That's going to be -4, right? Because only the 2 is counted as the base without the parentheses. Okay, what about the next one? -1/2 in brackets squared. What is the value of it? That's right. Because this time the minus sign is included in the parentheses. So the outcome is going to be positive. And then 1/2 squared is 1/4. So we have 1/4. That's going to be a positive 1/4. But we don't have to write the positive sign. And then what about the last one? -1/3 to the power 3. Of course, the -1/3 is also in the brackets. Yes. So first of all, we can see that we have a minus or negative base and an odd number power, which means that it's going to be negative. And then we are taking the third power of 1/3, which means that I have 1/3 times 1/3 times 1/3, which is 1/27. So then I just need to compare these three numbers. Which of them is the largest? Yeah, this one is definitely the largest, right? Like the 1/4. Because that's the only positive one. That's the only positive answer, right? Which means that this one has to be the largest. And which one is the smallest? So if you're comparing -4 and -1/27, which one do you think is smaller? Yeah, that's right. So you are very, very clever. -4 is definitely smaller because it is more negative, right? So if you're just trying to draw a number line there, well, say -1/27 might be there, just 1/27 less than 0. But -4 is 4 less than 0. So definitely it's going to be much smaller than -1/27, which means that this is the smallest, right? Yeah. So if I know that -1/2 in brackets squared is the largest and -2 squared is the smallest, the answer is going to be D, right? This is largest and that is the smallest. Does it make sense to everyone? Yeah, I can see that many of you are already getting the correct answer. D right there. Very good. That's brilliant. That's brilliant. Okay. Does it make sense to you? Why do you have a question mark right there? Do you find it confusing? Oh, yes. Okay. All right. So, last question for today. Exploration 4. Easy, isn't it? So for exploration 4, let's say n is a positive integer, which means that the two powers are going to be positive, being n and n adding 1, right? So what is the value of -1 to the power n adding -1 to the power of n adding 1? Yep. So probably I'm going to tell you two different ways to do it. The first way is that we are just going to consider the different possibilities, right? So say n is a positive integer. So it means that n is either odd or even, right? Say when n is odd, then -1 to the power of n is going to be -1 because I have a negative base and an odd power. So it's going to be having a minus value. Yeah. But then -1 to the power of n adding 1 is going to be 2. No, it's going to be 1. Because this n adding 1 is going to be even, being 1 more than an odd number, right? So when I'm adding them up, what I have is going to be -1 to the power of n adding 1. That's going to be -1 adding 1, which is 0, right? And similarly, that works the same way when n is even. So we can say that -1 to the power of n is 1 this time, but -1 to the power of n adding 1 is going to be -1, because this time 1 more than an even number is an odd number, and -1 is still a negative base, right? So we are getting a minus or a negative outcome, which means that in the second case, -1 to the power n adding -1 in brackets to the power of n adding 1 is still 1 adding -1, which is 0. Okay. So in both cases, it's going to be 0, which means that the answer is 0. And the other way we can think about this, if you are, well, if you're good enough in fast calculation or in the understanding of powers, so we can see that -1 to the power n adding -1 to the power of n adding 1 is equal to -1 to the power n adding -1 to the power n times -1. And we know that this -1 to the power n is actually equal to -1 to the power n times 1, right? Because anything it times itself, or itself times 1. Anything is itself times 1, right? So now, when I'm adding -1 to the power n times 1 to -1 to the power n times -1, I can extract the common multiplier, which is -1 to the power n. And then I multiply it to 1 take away 1, because I have 1 and -1, right? Which is multiplying 0. And we know that anything multiplying 0 is 0. So the answer is 0. That's going to be the second method. But then, for now, well, you can just try to know the first method. And for the second method, once you have completed the next lesson on the like the calculation skills or the fast calculation techniques, I think you'll be all good with that. All right, so that's going to be everything for today. And we will just have 5 little practice questions after the lesson if you want to consolidate whatever you have learned today. And yeah, I know, right? It's pretty easy. That was like 5 minutes. That's okay. So I'll pop the practice questions in the group chat later. All right. So yeah, just hopefully you can complete those within a short period of time and consolidate what you have learned. All right. Okay. So that's it for today. Thanks all for coming. Thanks. And I will see you all tomorrow. All right. Yeah, it is short indeed. It is. Bye bye, everyone. Bye bye. Thank you. Thank you for coming.